98%.
But the script that one has to write, one has to generate the traffic, right?
Yeah.
So can you give an example of what the script is?
Yeah, sure. All we are doing is we are making an HTTP request to this particular server, test.k6.io. And then once it is successful, K6 automatically interprets the requests that are going on, and it will generate a custom metrics out of it.
So if I want some more complex sort of a thing to happen, like go to this page, click on this element and things like that, how would I do it?
Okay, so
Something like Selenium does and all that.
yeah. So that when you say like you are logging into a web page, like there are a number of endpoints are right? There are a number of endpoints. What we have to do is that each of the endpoints, like we have to have a different functions for it. HTTP config. So that's what I quoted earlier as well. What you have to do is you run through the Chromium browser and then you record the scripts as HAR files. And then K6 is having an option to convert the HAR files to K6 scripts. Of course, like it will be kind of a preliminary script. You have to do some Java modifications.
But by using the, so what is there a plugin there to in Chromium?
Yeah, so there is something like if you go to Chromium browser, there will be something called as inspect element. Okay, you will be able to see across all the HTTP requests that are
right,
going into the Chromium browser, and then there will be something called as export as HAR file.
So after I do that entire thing, then I can look at all the requests and export that as an
HAR. And then you have to come over here, the K6 script, you have to run the K6 script which converts HAR files to the K6 scripts, and then you can.
And can K6 only be used with Kubernetes, or I can use it in anything?
You can run it on the local machine. See, when I say Kubernetes, right? So it's kind of a platform where I can run my K6 script. In our case, like what we did is we run it on our EC2 instances itself. Like we do the distributed testing. The reason behind it is like we have like limited number of users. We don't need to go that much scale. So that's the reason like we stick down to EC2 instances.
I can also run it on my local machine and
yeah, it's absolutely great.
One thing, like I've also used cases before. So one thing that we did, like we also did, we spun up another EC2 machine and we ran it from that. The problem with running from local machine is that it will also count the network latency to the cloud, and we don't.
Right. That's the reason. It's kind of a jump server. Right?
Yeah.
That's nice. That's the same problem here.
Yeah.
I didn't get Kubernetes things to could you just explain that in a minute?
Okay. I'll explain. So there should be some sort of an execution platform, right? For running my cases. The challenge that what we are having when you are running it in your EC2 instances, right? So the traffic will be coming from one of the regions, one of the availability regions, right? In real-time scenario, probably like if you are hosting Swiggy or like we will take some sort of a global examples, Amazon or something like that. The traffic will be coming from different regions and different availability zones. For that, like what we have to do is like we have to, in order to mimic that scenario, saying that the requests are coming from different things, we will be launching the K6 instances under different pods. Yeah. And each of the pods should be spread across different availability zones.
Across the
globe. And then that way we can distribute the traffic. We can distribute the traffic across the networks.
Origination of the traffic can be
come from across different sources.
This is done by K6.
It's not done by K6. There is something called as K6 operator. It's something similar to a Helm package. Like if you want to install any sort of application with Kubernetes, all you have to do is Helm install the package. So what it will do is it will literally take care of launching that application and create the service. Similar to that one, there is something called as operator as well. Operator is primarily used for mostly some sort of a service, something similar to Postgres or MySQL, not application related, some sort of a cross-cutting instance.
Do you have a sample HAR file? And,
right now, I can definitely share.
And with the sample HAR file, can you convert that to script? And
right now, I don't have as part of this one. I can definitely put it in.
the HAR file is easy to generate on the.
Yeah, that is easy. That's easy.
So is it the synchronized, like, let's say if I want to run a 1000 transactions per second, so will they be distributed equally, or can I compare, like, for US I want more traffic and from India I want more?
Okay, there is something called as execution segment. K6 execution segment, you can explore that option below.
And they are also good things, right? I mean, they know what other pods are doing, how much trade,
There is something what is you can do. What you can also do is you can do the real-time monitoring of your JMeter performance testing as well. So what we'll do is like we will do sending across all the logs, your K6 logs to the Prometheus or AWS cloud logs. You can do real-time monitoring distributed sets of. I'll show you. There is a command like it's very simple and configurable. You don't need to do anything.
This is primarily for performance testing.
Primary for primary performance testing, load testing, everything. You can do it for the kiosk testing.
So is it applicable only to the cloud applications or normal web applications?
Any web application.
Any distributed web applications?
Just a URL, right? Any API, any URL.
Similar to locust.
I don't know about locust. Like we have been using JMeter for quite a long time. Right? Similar to that one. But like JMeter is having its inherent limitations. Right?
Why is it less?
Yeah, it's very UA focused. And second thing is like you have to, since it is Java based, you have to configure across all the JMeter configurations as well. It's a little bit hard. But whereas like here, like it is Golang, so it's performance wise it's better. So what they are saying is like if you are running it in JMeter, you will be able to spawn across up to 1,000 concurrent requests. Over here, like it will be hundreds of thousands. That's the magnitude that we have seen.
So mainly the difference is advantage is distributed load and also the performance is better.
Performance is better, and third thing is it's configuration based. See, assume that like if you want to put it in your pipeline, CI/CD performance system, it's easy to do it. All you have to do is ask, shown here, like I have to just type in cross my command K6 transfer.
Question. So, as you said, you can scale it to hundreds of thousands. In your practical work, when you spin up one machine as a client to send out requests, how many requests can one client send out per? I mean, server can handle. I'm talking about how much. And the client manages.
Hundreds of thousands. That's what the claim is. But what we can do is
one single machine. I mean, I'm just trying to understand things.
no, that's practically we will not do it. That's a benchmark they have put across. What we'll be doing is like we will be doing distributed load testing. We'll be putting it in Kubernetes pods, and then that will be take care of this.
The pods will basically generate.
That's why it is unlimited. But on a regional basis, there must be some configuration that we
How do you set up?
How do you?
Or is it based on the number of pods that you say? Or how many pods? How many requests per pod for?
That is based on the configuration. You can put it up in the KC software. When you are installing it, you can
So what have you generally used?
see, like what we didn't really use across the KC software because we didn't do the distributed load testing. It's not in India. So as he said, as a gentleman said earlier, like we were launching it in the EC2 instance.
So EC2 instance, how big was the instance and what was the maximum load you had?
If I feel okay, if I remember correctly, like it was something like 16. I have to recollect it. Like I couldn't recollect right now.
We used a CPU optimized.
Yeah, CPU optimized
CPU
instance.
optimized.
I could recollect like what are the instances.
What was that CPU?
Some CPU optimized instance. I also don't
C5
remember
or
the.
something. C5 or something.
I don't remember the exact image.
Instance type.
Instance type.
Oh, okay.
It was C5 larger.
On the AWS, yes.
AWS.
So CPU optimized is a larger CPU compared to the RAM, right? More powerful CPU than RAM, that's what I assume. But I think the other question was like, if I want to say 100 requests from India versus 500 requests from the US, do you have like a common control? How do you do that? Based on the number of pods?
There is something called as execution segment. The execution segment. It's a little bit like I didn't cover up here. So we can explore across execution segment to use that particular scenario. For that particular scenario, we can use across execution segment. We can say that one from here, from this particular pod, like we can have this many number of requests.
So the Kubernetes support is not something that's inherent in K6. It's not a feature of K6, but that's more of a technique.
It's more of a technique. It's an operator pattern that we are using.
Yeah, even that's what I understand. So where you deploy, if you deploy your locally, you can run from your machine. If you deploy on Kubernetes, I think what he's trying to say is it's available to deploy in Kubernetes and you can test it. But if the JMeter and all, you can't do that easily. Right.
So you can do only HTTP based testing or gRPC also?
Supports gRPC support. But the older thing is like it's not.
So what should the frequency of when should we do performance testing? For example, we have some before putting it on to production, we did a performance testing. So what kind of changes should warrant
So general, there is no like control for it. Like general guidelines would be like whenever if you are going for various changes, or like if you, as I said earlier, if I'm changing like from MySQL to GAD or like MongoDB, some sort of major changes are there. Then like we will be going for the performance system. It's more of building a hypothesis and testing it whether it's okay. Like say that like if I'm moving it from MySQL to MongoDB, our time would come up and say like by 30% of the performance will be better in MongoDB. But how to do that particular part? So it's building a hypothesis and say that one, it's working or not. So as I said, if I just go back to the first slide, right, I would have mentioned across, I put across one formula, user load into response time. So it's kind of a hypothesis, like there would be an end state, like I want to reach across like 1000 concurrent users per second. That is fixed actually. So that's what the business will be claiming across. Like if you are doing it to MongoDB or something, I need like something beneficial. Okay. Some proof to say that one. And we will be doing iterations after iterations. As similar to JUnit or something, it's not a one-time exercise that will be doing it across. You will be like going for like 5 rounds or meaning bad in 5 rounds. We have done like some sort of competition that has gone for 10 rounds of that, which has gone for like almost close to a year.
But I think he also said about the CI/CD pipeline. So you could make it part of your pipeline so it automatically runs depending on whether you want to do it for every push or every release or whatever. Right?
usually it requires a lot of infra to be scaled up. So
yeah, it depends. I mean, you make the choice, but I think with the CI, it can
And one more thing is, here we have a performance testing which used to be a dedicated team for it. So which will be having its own subject matter expertise. Now, like I can bring in my front-end teams and my Java, like my own developer community to contribute to the cases. Because like it's not a configuration list. I don't need to have any special expertise. Like now the front-end developers will be able to develop across all these things.
So basically a developer-friendly system.
Yeah, you have like something called as Gatling as well. Gatling does also this thing too. Only limitation what it does is like it runs based on the JV. That's the only difference. Okay. And one more thing is it's bought by Grafana Labs. So that's the reason like it's speaking in the same way. And Grafana is having its own cloud environment as well. Like say for example, like if you don't want to launch your EC2 instances, they are providing across some sort of cloud hosted instances. That's right. Grafana cloud hosted. You don't need to do that. When it comes to performance testing, our objective is to mimic the real-time production scenario. When I say mimic the real-time production scenario, there can be two things that can be done. One is from an execution point of time, and second thing would be how I simulate across a production data. When I say simulate the production data, probably I can't use across the same data. I assume that like I have been asked to develop a script. I shouldn't be hard coding it as 1, 2, 3 on this. What we do in JUnit or integration testing is we put across the same name or phone number again. But when it comes to performance testing, it's like we have to have like various data, the domain of data should be different. Reason is, I'm just going back to the same thing. I'm just doing it from the relational array to distributed arrays. So I just need to check whether the sharding works properly. For that, what I need to have is the sharding is based on my country location. So I need to have like some sort of a range of countries that is getting populated across. It shouldn't be always India, it should be across different locations. So that's what like there is something called as shared array. there is something called as faker library. The faker library, what it does is it fakes the data. Okay, there is no guarantee that what data will be coming across. It will just fake the data. It will be like ABC, XYZ, as simple as it. And then there is another thing called as shared array. What we can do is we can read the data from the external sources. It could be from any source. And then once that information is available, I can submit that information to my virtual user function. What it will do is it will dynamically pull the data. When I say dynamically pull the data, probably like I can have an array of objects, and I can pull that information and then I can execute it. So this is what I mentioned here. So I will be creating across a shared array, and then I will be passing that information, and that information like will be executed in the K6 script. One more thing that what K6 also does is it will be also well aware of the context. When I say aware of the context, it knows what's the iteration that I am in, who's the virtual user using, and how many number of iterations you will complete it. Once I have all this information, if I have array of objects, what I can do is this many number of iterations is completed. So move on to the next index. So in that way, I can spread across my request data across various things. So what I mean by here is, I'll just explain what I mean by it. And one more thing is, the shared array, we will not be able to do the cross communication. So when I say cross communication, I can't say that if I can't mutate the data. When I say mutate the data, probably like I can't say that in virtual user 1, the particular entry from India, the data has been processed, and that needs to communicate to virtual user 2. That can't be done in shared array. If I show the example, it will be easier. So this is script for data parameterization. As you could see across here, right? So this is the basic script that's getting executed across. And what you see over here is the faker phone number, everything is like kind of a constant thing. If you just put across faker.phone number, every time it will generate across a new phone number. This is one way of doing it. Other way of doing it is I can pull that information from external sources. In this case, like it will be customers.bc. So I'm having a list of customer names and the respective cities. Name Abhishek, city name. So what I want to do is this performance is to group through this particular things. It should be any of these ones, any one of these objects that can be used across. In real-time testing, like it will be like 1000. You want to put it as 5. Just for explanation perspective, I put it as like 5. Or I can read from some sort of a Redis as well. That is also something that you can do.
This faker, like we put constraints like for example, you said email needs to have accurate, phone number should be carried.
Like that's what I mentioned. All you have to do is, there is a set of inbuilt objects that are already available. All you have to do is faker.phone number. It will automatically generate you the phone number. Phone number, and it will be dynamic as well. When I say dynamic, I will execute and show you across. You see here, right? Every time when I execute it, it randomly puts across a name and phone number. What you can also see is, I have pulled it from some sort of an external source. That is also a little bit dynamic as well. First time it is Abhishek, second time it's Abhishek. One more thing that what I want to explain is this one. There is some sort of predefined constant values that will be available for a particular virtual user. It is nothing but execute.view.id instance. So this will tell you, this is my virtual user ID number. Probably for every virtual user, I will be having some sort of a number, 1, 2, 3, 4. And there will be something called as iteration completed. there will be one more constant called as iteration completed, which will say like, I am in which iteration. Okay. So if I use both these things, combination of failure and this thing, I can put it from saying that I need a 100th object, or if I need across 101th object. It's all about manipulation across faker, then a shared array, and this third thing. If you do the combination of things, like you can do different steps. This is a core part of K6, simulation of real-time traffic. So when I say that one, there is something called as executors, okay, in K6. Say for example, like if you are doing a performance system, we will take the example of say Swiggy array. If you see the real-time traffic of a Swiggy array, the traffic will be very high between on the breakfast time, between 9 p.m. and 9 a.m. and 11 a.m. and again between 1 p.m. and 3 p.m. Again the traffic will be higher on the evenings. At all other times, the people will be searching across what are the restaurants that are available near. It's as simple as that. But how do we simulate that sort of scenario in the performance testing? There should be some sort of a ramp up and ramp up. How do we do that? So this is what the execution framework does for execution. Okay. And there are different sort of execution engines that are available. There is something called as ramp up. So what you do is you can just tell for first 100 requests, like it will be which it uses just like 5 or 10. And after some point of time, after 30 minutes or so, ramp up to 1000 concurrent users. And then after some point of time, slow down and then bring it to 0. This is one way of doing it, mimicking the scenario. And there will be another sort of request, something called as constant views. So the constant views, it means that there will be always some sort of active request that will be coming to my system, irrespective of any time. So when you are simulating a real-time production scenario, right, you need to combine both the scenarios, my ramp up as well as constant views. There are other things that are also available. There is something called as shared views as well. So what it means is when you say shared views, it will run like that many number of times. Or if I say just I need 100 iterations, okay. So that 100 iterations will be spread across probably across 3 virtual users. Immaterial of what's the time that is getting. This is one other thing. Again, this is also configurable. Like if you go to JMeter, which you need to do a lot of configurations for it. So for simplicity's sake, like I just put across, I use across the K6 endpoints as well. I have something called as check orders and check reviews. So if you see here, order request will ramp up throughout the day, right? It will ramp up during my night times or like it will be ramping up during the morning times. It will be one of those. Reviews can like order checks or like what sort of products that I'm going to buy. That will be happening throughout the day. When I say like I want to search across whether it's called the smartphone or something like that, that will be happening throughout the day. For combining both the scenarios, what I can do is I can just specify across. I need a couple of scenarios for me. One with an executor framework called as ramping views, and other is constant views. If you see the ramping views, you will be seeing across what is my start view. Like initially, like it will be the number of concurrent users will be 0. And what I need to execute across, I need to execute across check orders. And what are the stages that I have? So for first 20 seconds, it's going to be 10 concurrent users. And for after 10 seconds, it needs to slowly ramp down to 0. Okay, this is one way of doing it for the order check. And check reviews, it will be happening consistently. For the what I will be specifying is, it will be constant views, and then I will be executing across check reviews. The number of virtual users will be always 5, and it needs to execute across for 30 seconds. Both the scripts will be executed for 30 seconds. But only difference is, this is going to happen quite often. Okay, with consistency. But over here, the number of virtual users that are happening will be increasing throughout the day. This will be especially useful like when you are doing across a load testing. If I just run this one here.
The reports are always in this form, or we can
You can change it to JSON.
HTML.
Anything is possible. We change it to HTML. Yeah. So if you see over here, right, there is a couple of things that you are seeing across. One is the number of virtual users, right? Here, like, it is always 5, but if you see here, it's increasing over the period of time. This is sort of slowly to increase. And as the execution is completed, it slowly ramp up. So that's what the difference between this constantly and the ramp up or ramp up. So if you see here, orders, there is something called this. I can have minimum as 5 concurrent users and maximum as 50. Anything when it is, there is two sort of columns that is running. One with the 5 and other can go up to 10. So it will be, minimum will be 10 and max will be 50. So this is what you are seeing. This we already saw it to an extent. So there is something called as metrics. At the end of it, like if you do any sort of testing, like you need to collect some local metrics. There is something called as system metrics and there is something called as custom metrics. So K6 inherently captures few of the metrics. That's what we are seeing just now, right? And there are like 3 sort of metrics that are there. One is counter, and second thing is wash, and third thing is trend actually. So counter is nothing but it will increment. So that I can use it across this. I want to just find out how many number of 200 requests that I have, how many number of 203 requests that I have, right? So within my request file, like I have to expand the code immediately. And second thing would be trend actually. So whenever like you do performance testing, right, we will not be going with average. There is something called as P90, P95 and P90. These are the 3 things that we will be focusing on. Mostly it will be between P95 and P90. The reason behind it is how my top 99% of the request is performing. Most performance. If you go by average, it will be a little bit biased. Because like if there is one outlier, that will stood out actually, like it will be like 1000 milliseconds. That's the reason like we shouldn't go for an average. We should always go for a P99 or P95 to an extent. If the endpoint is little bit like somewhat shaky, like you can go for 280. That is what this trend is. And the custom metrics. Why we need custom metrics is I'm submitting a request. Probably like there could be different failures. Probably like it could have some sort of a token aspect as part of the request. And there could be some sort of an authentication failures or authorization failures that could happen. That and all shouldn't be counted in my metrics as such. If that will be, there will be some sort of bias like if I have that information inside my system. So what I'll be doing is, we will be building across something called as custom metrics, like custom HTTP 200 status counters, 403 status counters. We will be checking across what's the status of my request, and then like we'll be having different counters for it. And then equally like we can have the trends as well. This is the trend for 200 requests only. So that my authentication and authorization failures can be diluted, but it's not required for my analysis. I'll show the example as well.
There could be some cases where we really want to measure how the authorization and authentication, because I'm trying to figure out how fast my backend is.
That will be a different endpoint.
Yeah.
But within my business endpoint, if my business endpoint fails because of my authentication,
yeah,
that will
that's
be
it.
another. It's all possible. So if I see that like none of the requests I paid for 403 reason, that side is only versus because HTTP 200 status control. So all my requests have succeeded and just having HTTP status control. I can have one more end as well for HTTP 200. So I introduce the website. This way. If you see across here, HTTP 200 status control, then
Hollywood stats by
it's not per HTTP status. Yes,
by
HTTP status.
Then I think if you use 401, the average will come down.
Come down.
But actually,
Really, like we will not be needing that much. And finally, like one gentleman asked about like how can I do across real-time monitoring infrastructure for this system? All you have to do is have to put across KC strand, -out, output stars B. If there is any monitoring process that are available, it will put across this chart. So this is a chart that is generated out of HTTP. It will say across how many number of views are there, request duration. How I shown across like in the console, right? The similar thing like you can see it across in the pages as well. Like how we can do this, like if you are doing a really distributed load testing, the request will come across from different formats. You can send it across to Prometheus server. In Prometheus server, like you can do the real-time monitoring. Yeah, that's it. And all these things is available in my GitHub. The entire source code is available in PSS.